Hello all, happy weekend. I'm going to go over 6.7 now, and I've intentionally put the video into the left-hand corner because I'm going to be doing quite a bit of drawing off to the side. So this is graphing inequalities. It's going to be a little bit different. I'm going to go through a lot of examples, and then the last several slides will all be the examples that you will be expected to try. So let's go ahead and take a look at this first problem. So just to warm up, if we have this point as our solution, we need to find out if that point is a solution for this inequality. The way that I would do that is by remembering that all of our ordered pairs are x comma y. Therefore, we'll plug x is -6 and y is 3 and say, okay, well, -6 plus 3, that's equal to -3. Is -3 greater than -3? No, it does not. Therefore, the correct answer is false. Similarly, if we took a look at this one, we would plug 3 in for x, which would make this be 12. And we would plug in 2 for y, which would make this equal to 14. Which would mean that 12 plus 14 is equal to 26. Is that less than or equal to 26? Yes, it is, because it's less than or equal to. Okay? So, on the next example, I'm going to have you try it on your own, just as a little warm-up. So go ahead and give it a try, and that will be your first example. So for this page, let me just point out a couple things. Isolating y isn't totally necessary. However, when you're using your calculator, it will be. I'll show you how to use your calculator on Monday. The first key point is right here, which is that anytime you have a less than or equal to or greater than or equal to sign, your graph will be a normal solid line. However, if you have a less than or greater than sign, it's going to be a dashed line. I'll show you what that looks like in a moment. But the last key point is very important. You're not going to know what it means yet. I'll talk about it in a second. And this isn't completely true. I would test 0, 0 most of the time. However, there will be times when 0, 0 doesn't work. I'll talk about that in a minute, but I just wanted to give you a second to write down this portion or take a picture or do whatever you want so that you have this information down before moving forward. So let's take a look at this problem. I'm going to go ahead and graph it just like I would graph a normal equation. So I'd start off writing my m equals and my b equals. My b is 1. My m is going to be 2, which is just 2 over 1. So I'm going to go to the point 1, and then I'm going to go up 2 over 1, up 2 over 1. The next piece is looking at that sign. Because it's a less than sign, that means it's going to be a dashed line, like so. The last step is very important. Because we're talking about an inequality, we're talking actually about a group of points. There are an infinite number of points that could make this true. However, they lie within a certain region. Now, this is important. The origin, or point 0, 0, does not lie on the line. Therefore, I can use it to test my graph. Okay, so what that means is I'm going to plug 0, 0 in for my points. So I've got 0, 0. So that means I'll have 0 less than 2 times 0 plus 1, which means that 0 is less than 1. That is a true statement. Therefore, since 0, 0 lies on this side of the line, and it is a true statement, that means that I shade this side in, because what I want to do is shade in the side that is true. Because that indicates that every single point that lies in this entire region will hold true as a solution for this inequality. Let's try another problem. So again, for this one, first step, m equals b equals. So b is -5, m is 2 over 1. So I'm going to go to -5 Then I'll go up 2 over 1, up 2 over 1. Again, it's a greater than sign, so I'm going to go ahead and make a dashed line rather than a solid line. If it had been a greater than or equal to sign, it would have been a solid line, but since it's not, it is a dashed line. The next step is checking to see if 0, 0 lies on the line. And since it doesn't lie on the line, we are allowed to use it. So I'm going to plug 0 in. I'm sorry, 0, 0. So I've got 0 is greater than 2 times 0, which is equal to negative 5. That means that 0 is greater than negative 5, which is again true. Since it's true, we shade in that side. And that will be our final graph. If it was false, we would shade in the side that did not contain 0, 0. So let's take a look at a few more examples. Alrighty, but before we take a look at a few more examples, try to give these ones a shot. See if you can get them right. I'm not going to be checking to make sure you did it, but just give it a shot before playing the video any further. Hopefully you found out that this was the correct placement. If not, don't worry, we have examples to come. Alright, so let's take a look at this example. We know that anytime we have x equals a number, that number is that means it's a vertical line. So just looking here, it's hitting at x equals negative 2. Therefore, this isn't going to be the right answer, nor will this be the right answer. The second thing we can look at is the fact that it's a dashed line, meaning that it must be C. If it had been a solid line, it would have been B. So looking at this example, similarly, we can automatically eliminate these two because those both are greater than symbols, which means that they should have a dashed line. Now these are both, this says 1 and this says negative 1. Since this is hitting at 0.1, that means that that must be the answer. So what about the shading, you might ask? So before showing you another example, please try this example on your own. I'm curious to see how you do. Okay, so in this next example, it's already put into standard form, see? And we can solve this one of two ways. I can either put it into y equals by adding 2x to both sides, and I'd have y is less than or equal to 2x minus 4. I could have also solved for my my x and y intercept by plugging in x equals 0 and y equals 0 and then solving for the intercepts. But since it's already in this form, I'll go ahead and use it. So m is going to be 2 over 1, again, unintentionally. And b will be negative 4. So I'm going to go to negative 4. Then I'll rise 2, run 1. Rise 2, run 1. It's a greater than or equal to sign, so I'm going to go ahead and make a nice, pretty, solid line. And my last step is seeing if the origin is on the line. Since it's not on the line, I can use it. If, hypothetically, it was on the line, like something like that, I would have to choose another point off of the line. A good point might be something like 0, 1 or something. Because if it was on the line, it wouldn't tell us anything about the graph. And I'll talk more about that in person on Monday, because I realize it's slightly confusing. But again, since 0, 0 is not on the line, I may use it. So I'm going to plug 0, 0 in for y and x. So I've got 0 is less than or equal to 2 times 0 minus 4, which means that 0 is less than or equal to negative 4. Is that true? No, that is not true. 0 is not less than or equal to negative 4. Therefore, the origin lies on the side that is false, meaning that the other side is true. You see that? Meaning that every single point that lies on that side will make this equation true. So for these last few examples, I'd like you to try them on your own, starting with this. Go ahead and give this one a try on your own. Continue trying with this next problem here. You can again solve this either as standard form or you can set it into y equals. And that is the final slide of the lesson. I realized that I didn't do anything off to the side, and that is the secret thing, that I moved the thing over to the left and then I didn't actually use the space. Yeah, it was totally intentional. Why wouldn't it be? Alright, you guys. I will see you Monday and have a wonderful weekend. Don't get into too much trouble.